When I was in graduate school, many moons ago, back in the 1980s, I was in graduate school to get a PhD in astrophysics. And when you're getting an advanced degree in the sciences, especially in the physical sciences, what you notice is that other graduate students, many of them, and in some departments, most of them, were not born in America. They came from other countries around the world. These are countries whose system of education did not extend deeply into graduate studies in the fields of their interest. And so they had to look around the world to see who could serve those interests. And in the physical sciences, the United States had led the world. Half of my fellow graduate students were foreign-born nationals. And this was not uncommon. In the physics department, it was even higher, that fraction of foreign-born nationals. And for most of them, they'd get their graduate degree and they would find job opportunities here in the United States and they would stay. Now, I took that for granted. It was like, well, of course they're coming to the United States. This is America. And I didn't fully think about what might be the consequences to the country from which they came. This was tantamount to a brain drain from those countries. And those countries would not then be able to create a layer of science, technology, engineering, and math to build their infrastructure. They'd be beholden to advances from other countries that had the innovation and the educational tracking to create that kind of a world. So I just took it for granted. I didn't think much about it. It was like, of course, they're here to study these subjects. Recently, in the United States, science as an enterprise has not been as welcomed or as supported as it has been in previous decades. This manifests in multiple ways. We've already talked about the halving of the science budget of NASA. By the way, that might not look like much on the total NASA budget, because NASA puts astronauts into space and lately to the moon and back. That's not the science budget. The science budget is a fraction on top of that allows us to put up space telescopes to search for life on Mars and on moons of Jupiter. It's all the images we get and the knowledge gleaned from the space telescopes, such as Hubble, such as the James Webb. That's the science budget. You could have a space program without science, but then what is motivating it? Is it muscle flexing? We can go into space and you can't, or you don't know how, and we do. The science makes space exploration a noble enterprise, rather than just a simple race that you've decided to hold. That's NASA, but let's keep going. I don't know if you knew, but from academia, the government has had visiting scientists annually come in from academia to serve the country. These are scientists that come in and advise the Justice Department, the Senate, the House, the White House. These rotating positions were not only good for the government, they're also good for scientists themselves to get a taste of how the sausage is made in governance, especially when governance needs and relies upon the advice of scientists. So here's what has happened. Many of those positions that rotate in and out no longer exists. These rotating positions included, for example, the National Science Foundation. You'd have scientists from academia doing tours of duty in and out of the National Science Foundation to bring their expertise into a government agency that doesn't always have access to the moving frontier of that expertise. Not only that, what does the NIH do? The National Institutes for Health? They have grant money that goes to research that's not conducted within the government. It's conducted by scientists in universities. This is one of the fundamental roles American universities have played in the strengthening of the United States in the 20th century. Universities are not just some places students go to learn and get degrees. Yes, it's also that, and yes, it's importantly that. But the intellectual capital that resides in the scientific community of universities has no equal in the world. And the government knows this. So the government says, we want to do some extra research here and there. We don't have that expertise. Here's grant money to the university, go build a lab, do the research. Not only that, what we have learned in 20th century research in science is you cannot predictate what role and value curiosity-driven research will play in the future of your economy, in the future of your health, in the future of your security. You cannot predetermine that because you have no idea. You might have read recently that research into the venom of the Gila monster, this big lizard, research on that venom led to the development of the GLP-1 weight loss medications. Who would have thought that? Maybe not even the scientists themselves. The point is, curiosity-driven research extends the frontier in all directions, and you don't know in advance what connections will be made off of those frontiers. You don't know. My college physics professor, his name is Ed Purcell. I took quantum physics from him. This was well after he had earned a Nobel Prize. For what? For discovering a new physics phenomenon called nuclear magnetic resonance. This is what happens when you take the nucleus of an atom, subject it to a strong magnetic field, and you watch the effect on electromagnetic energy passing by it. Later on, medical technologists say, wait a minute, if you can distinguish one atomic nucleus from another in this way, then maybe I can make images of the soft tissue of the human body in ways that X-rays do not reveal. Thus was invented the magnetic resonance imager, the MRI. Its full name would really be the nuclear magnetic resonance imager, but nuclear is one of the two N words you're not supposed to use in polite company. Anyhow, MRI, arguably the most potent machine in the arsenal of the medical community to diagnose the condition of your body without cutting you open first. That came from the work of a physicist doing research on atoms and molecules, who, by the way, was deeply interested in atoms and molecules in space. That was his calling. That's what got him interested. And here he is doing research, a person who has no interest in medicine. The intersections of the frontier, of the moving frontier, in ways you cannot predict, is what defines our exponential growth in our science and technology that drives society. If you think science is some hidden activity done by ivory tower institutions just for the amusement of scientists who have nothing better to do with their brilliance, so therefore you don't really need them. What you really want are the engineers, because they build stuff. And if you're an engineer hired in a corporation in the R&D department, what fraction of their money goes to R&D? Anywhere between 0 and a few %? All right, you're gonna be tasked with making product that'll show up in the quarterly report with promise of revenue. Well, when you're doing science on the true frontier, there's no obvious pathway to revenue, certainly not in the quarterly report, definitely, and not the annual report. If you had a decadal report, maybe. We're in the 100-year anniversary, the centennial decade of the discovery of quantum physics. People back then said, I wonder what molecules are doing. I wonder what atoms are doing. If you were around back then, what would you have said? I'm a carpenter, I just care that my wood atoms can cut. I'm learning new laws of physics about how particles interact, how electrons, protons, neutrons, quarks, other particles, too innumerate to mention here. It would take decades. Yes, decades before we would discover how to create, store, and retrieve digital information. You know how you do that? Using quantum physics. Oh my gosh. Who in the 1920s would have said, we're doing this because one day we'll have personal computers? No, nobody's thinking that. This is all backdrop to my point. Within the last 2 years, we've lost more than 15,000 scientists from the ranks of the federal government. Not only that, grant money from major funding agencies of the government has been reduced so that we have fewer scientists doing research on government funding. You look at the titles of some of the papers or the titles of the grant proposals. They have a research paper that maybe 100 people in the world at most understand the title. And it's like, I don't see why that's relevant to anything. Therefore, I don't want to fund it. Let's cut it. And then you cut it and it looks like you're saving money when what you're doing is you're cutting out at the kneecaps the future competitiveness of this nation in the three things that we care most about: our health, our wealth, and our security. Because the history of that exercise tells us exactly that. The government loses 15,000 scientists, and if you think all the science research you need to do is on the R&D ledger of a corporation, you are sadly mistaken. So what is happening? Our labs here in the United States, the funding is dropping. We can't sustain the lab. We can't sustain graduate students, postdocs. What's a postdoc? A person who gets a PhD and still has some energy and some creativity to do some research. They don't want to be a professor yet, so they get to spend 3 years, 4 years, 6 years doing just research in a lab. You don't have money for that as the person who runs the lab evaporates. Do you realize I have colleagues who've gotten a phone call from Germany, from France, from Spain, saying, we've got a fully funded lab here. I know your expertise and I know you're running out of funding. Why don't you bring your whole operation to us? We're now getting cherry picked by other countries. Yeah, that's what we kind of did for the second half of the 20th century. But now the tables are reversed. We're losing our scientific base. Europe understands what's going on. You know who else understands what's going on? China. Here's an interesting vignette about China. Initially, Chinese students came to the United States to study graduate subjects in the physical sciences, and they stayed. Meanwhile, China is growing. China's economy is growing. They're getting their act together. Have you seen pictures of Shanghai lately? Any part of it? This is a city of the future, right? So meanwhile, China's ascending. So what happens? The next generation of Chinese graduate students, because that first generation came and stayed. The second generation got trained and went back to China to build the next generation of graduate programs. The third generation of Chinese graduate students are not here because they're being trained in China and they're staying in China. This is a slide. It's not a cliff. If you fell off a cliff or were pushed off a cliff, you would notice that, but it's a slide. And as we continue down this slide, and as scientists are cherry-picked, as labs are evaporating, as scientists are retiring and not replaced, there's an intellectual vacuum, scientific vacuum that is descending upon the United States. And that has consequences. I'm not here to tell people who to vote for or what to vote for or who your candidate is. It has nothing to do with this. It has to do with an if-then statement. If you're okay with the United States losing its scientific leadership, especially in the physical sciences, if you're okay with that, you will get the country you voted for. And that country is one where we will no longer innovate because our greatest innovations are based on the frontier science that's way beneath them, hidden from the daily news reports, hidden from what you see and hear about as you surf the internet. That goes away. We lose the foundation of our innovations, and the United States fades on the world stage. And they will do things that will impress us, just as we did things my entire life growing up that impressed the world. We went to the moon. Nobody else was close to going to the moon. As a scientist, it kind of doesn't matter who's making the advances because the fields of science move forward. But as an American, I like baseball, I eat hot dogs, and I eat apple pie. Yeah, I'm American. It kind of hurts to watch this hard-earned leadership evaporate. We will be less secure, less healthy, and less wealthy because some community of people who influence what this country is do not see the value of science deep below all of that. I'm saddened by this. But let me put this on a higher note. Remember when the folks were testifying about aliens in the back shed and reverse engineer of alien spacecraft and flying saucers? Remember that? Okay. These were hearings in Congress. Who was conducting those hearings? Members of Congress. Both political parties of Congress were sitting right next to each other, hand in hand, asking common questions. That was my takeaway. Aliens was something everybody cared about, and your political persuasion didn't matter. Aliens. It took aliens to bring us together. Ronald Reagan predicted that in 1987, I think it was. He gave a speech in front of the UN.
I occasionally think how quickly our differences worldwide would vanish if we were facing an alien threat from outside this world.
There would be no Cold War because we'd be in this together fighting a common enemy. I don't like common enemies to be the source of us getting together, but yeah, that kind of works, doesn't it? All right. As we fade and as the rest of the world rises up, and as we in the United States decide we need to do something about it, I think then we're going to be sunk so deeply into a hole that all political factions will be together and say, we got to get out of this hole. How are we going to do that? Well, we got to shore up our scientific profile because there's nothing political about science moving on the frontier. Yes, funding can influence what science gets done that is shaped by your political policies, sure. But the discoveries that science makes, those are not political. That comes out of nature. Nature is the ultimate judge, jury, and executioner of what happens in the laboratory. Okay, so we're down in the hole, looking up. And the only way out is straight up. There's no room for political bickering. We've got to do this together. And I think we will descend further before we reach that point. But the day we reach that point, I think we'll rocket out of that hole as no one could have imagined. And why do I think that? Because we've actually done that before. What happened on October 4th, 1957? Soviet Union launched Sputnik, a radio transmitter embedded in a hollowed out intercontinental ballistic missile shell that was flying over our heads. If they could put that over our heads, they could put a nuclear payload over our heads. We got spooked. Within a year, we created NASA. Within 11 years, we orbited the moon. Within 12 years, we were walking on the moon. Yeah, we rocketed out of that hole we were in to try to show the world the path of freedom over then known as the path of tyranny, the godless communists. Oh, you want another example? December 7th, 1941, we're attacked at Pearl Harbor. Oh my gosh. We gather our resources, our scientists, our corporate infrastructures, our military. Do you realize we isolated the element plutonium in the year 1940? And within 5 years, it was weaponized. And that was the first atomic bomb ever detonated at Trinity Site, New Mexico. Shortly after that, a duplicate was made, perfected, and dropped in warfare. All that happened within 4 or 5 years. Think today how long construction projects take. You build a road, a bridge, they take 5, 6, 7, sometimes 10 years. When we're motivated, evidence shows we can rise up as a nation, as one nation, to achieve a goal, provided we understand what that goal is, and we understand what methods, tools, tactics, efforts, and investments are required to stoke that goal. That's the America I look forward to in this, our 250th anniversary. As a kingless country run by its citizens, let's take the world back. I know that's kind of jingoistic, but I can't help it because I'm American. Neil deGrasse Tyson for StarTalk. This is a What's Up With That? Until next time, keep looking up.